Welcome to this explainer. Today, we're taking a pretty mind-bending journey through spacetime to answer a wildly counterintuitive question. Why does simply existing require active work, and why does forgetting carry a strict, literal physical price tag? We're going to see how memory, erasure, and relativity all tie together perfectly in the fundamental laws of physics. Here is our roadmap for today. We're going to cover 1. The law of perpetual change. 2. The physical cost of forgetting. 3. The space-time speed budget. 4. The arc and the chord. 5. The plateau of slow reality. And finally, 6. The price of persistence.
All right, let's jump right into part 1, the law of perpetual change.
So this whole concept starts with a foundational law of reality known as the no fixed point axiom, or C1. It states very simply, nothing can fail to change. In our universe, stopping isn't just difficult, it is physically impossible. There is literally no operation in the entire cosmos that simply does nothing. Basically, a fixed point, a terminal state of just sitting perfectly still, cannot exist as a valid coordinate in the universe. Since you can't just freeze, every single transition from one moment to the next absolutely must discard some prior information to make room for the new. I mean, think about it. If a successor state kept absolutely everything from its predecessor, no change would have actually occurred. Difference is required. Change is the absolute currency of reality.
Moving on to part 2, the physical cost of forgetting.
Okay, so every time a state is left behind, a record gets erased. And according to a concept called Landauer's principle, logical erasure demands a literal physical energy payment. Specifically, at least kT natural log of 2 of energy, which is dissipated as heat. The universe strictly bills you for every single record you drop. Let's break that logic down. Difference requires an absence, right? And absence is inherently a discard. Therefore, change has a non-negotiable floor price, and that price is paid in erasure. You literally cannot change without forgetting, and you cannot forget without paying physical energy. It's an inescapable loop.
Which brings us to part 3, the space-time speed budget. This is honestly one of my favorite, most mind-blowing ways to look at special relativity. You are always moving at the speed of light. Always. But you have to split that fixed speed budget between moving through external space and moving through your own internal time. It's an equation. V space squared plus V time squared equals C squared.
So how exactly does that budget split? Well, if you move quickly through space, you fundamentally have less budget left over for internal change. The universe strictly limits your total budget, and physics calls this internal change budget your proper time. Because of that split budget, your proper time, and therefore your absolute cost to forget, scales exactly as this famous relativistic factor, the square root of 1 minus beta squared. It's simple. The faster you move through space, the less internal time you accrue. Fewer recorded states means a much cheaper bill when it comes time to forget them.
Let's look at the extremes of this in part 4, the arc and the chord.
Imagine a photon traveling at the speed of light. It cuts a blinding, linear chord straight through space-time. It accrues absolutely zero internal proper time, realizes no intermediate states, and therefore leaves zero history to erase. It basically costs nothing to forget. On the flip side, an object completely at rest traces a rich, glowing golden arc. Because it spends its entire speed budget internally, it visits every possible internal state, maximizing its record and completely maximizing the thermodynamic cost of erasure. You see, proper time is not just some ticking clock on a wall, it is the physical clock of decay. It's the exact measure of the internal states an episode realizes. What is incredibly expensive to forget is exactly what has lived the most internal time. A photon carries no forgettable history, but a body at rest, it carries all of it.
Now for part 5, the plateau of slow reality.
You might intuitively think the cost drops off linearly as you speed up, but it doesn't. If you travel at 50% the speed of light, forgetting is barely any cheaper. You literally have to reach a staggering 86.6% the speed of light just to cut your cost of forgetting in half. What this means is that everything in our slow, everyday world sits high up on this plateau of reality. Because we humans operate nowhere near the speed of light, the things we experience are universally and incredibly expensive to forget. Cheap forgetting? That is strictly a relativistic effect reserved for the near light speed limit. Ordinary experience demands the maximum possible physical toll to erase.
And that brings us to our final section, Part 6, the price of persistence. So, if a change is real only if it leaves a measurable, equal and opposite shadow, what does it actually take to wipe a slate clean? According to this framework, there is no magical delete key you can just press. Because forgetting costs exactly what recording cost, a high proper time episode cannot simply be zeroed out. The universe outright rejects the shortcut. Instead, it has to be actively discharged by walking the recorded shadow back to its origin step by step. A full round trip, recording forward and forgetting backward, nets to zero, sure, but you have to pay the toll in both directions. So persistence is actually not a failure of forgetting, it's the exact price of it. An intrusive, high-detail memory resists erasure because it is fundamentally a massive space-time debt that hasn't been walked backward yet. A large record simply is expensive to discharge. Persistence is an active, undischarged traversal. I want to leave you with this final thought to ponder as you navigate your own internal clock of decay. If our very existence relies on constant change, and if letting go requires actively walking back our deepest shadows at a massive thermodynamic cost, what is the true, physical price of the memories you refuse to let go of? Thank you for exploring the architecture of reality with me today. See you on the next explainer.